Good evening. Hello. Hi. Wow, such a warm welcome. Thank you. Welcome to first round of lightning talks. I hope you all had a good conference so far and an even better lightning talk evening, maybe, I don't know. My name is Lynn Root. I am your lightning talk chair. And if you're interested in giving a lightning talk, you can give your pitches. You can sign up right next to the left of registration for Saturday evening and Sunday morning. But yeah, let's get started. Our first talk of the evening is Katie, whose title of the talk is Lightning Talk Cover, Emoji Archaeology 101.
This should be fun. Good afternoon, class. Unfortunately, Dr. Keith McGee has taken down with a case of yak shaving, so I'll be your substitute teacher today. This is Emoji Archaeology 101. Let's get started. In 1963, the human emotion of happiness was created. It was created by the American Harvey Robo, who was employed to create the image of a happy face to raise morale of employees within an insurance company. But once people discovered that it was possible to express emotions, they wanted to express emotions of their own. In New York, in a New York Times interview in 1969, Vladimir Nabokov said, "I often wish there was a special typographical sign for a smile, some sort of concave mark, a supine round bracket." And in 1982, Scott Farlam had a breakthrough when he proposed the composition of 3 different ASCII characters as a trigraph to express the human emotion, happiness. Although these code points don't in themselves represent any emotional context, if composed horizontally, they combine to produce a powerful expression which the user can comprehend simply by turning one's head 90 degrees to the left. While happiness does have a significant utility as an emotion, users felt that it was not meeting all their needs. But however, by replacing the third code point, the much more functional expression of unhappiness could be expressed. This, ironically, led to much more higher levels of happiness, since users were now able to voice their displeasure at anyone who disagreed with them. Thus began a Precambrian explosion with the expression of emotion, as such users realized the hidden potential of the ASCII Unicode code set. The first changes were simple issues of ergonomics. By reversing the code point order, it was possible to evenly spread the physical exertion required to observe emotion. More sophisticated extensions were then added, such as the adornment, wearing of glasses, or optical tiredness from staring deep into the ASCII code chart looking for emotional inspiration. There was even a move to represent more extreme emotions, such as extreme happiness. Some of the extremists could not be kept to just 3 glyphs. They felt the introduction of a 4th glyph to demonstrate scorn or to embody a single tear rolling down the face. Some purists felt that the 3 code point limit should be retained, so they compressed complex expressions by losing the fidelity of nasal expression. Others felt that didn't feel constrained by the NRE constraints, allowing further rendition of, say, the absurdist philosopher Homer Simpson, or the beneficent midwinter courier, Santa Claus. Others revisited the premise that emotions could be expressed horizontally and looked to the perpendicular as a presentation style. However, the US ASCII code set was reaching its limit at this point. Thus, the introduction of Unicode, a vastly more complex set of alternatives which enabled the construction of much deeper expressions of emotion. It is not clear in the literature whether any of these glyphs were actually used in their languages of origin. The schism between minimalists and maximalists in the expression of emotion reached its zenith with this pair of expressions, the 11-character table flip as the ultimate expression of anger, and the single katakana character as a simple expression of happiness. Unfortunately, pressure was placed upon the Unicode Consortium to allow more literal expressions of emotion. This started with simple renditions, but over time, these expressions became much more literal, removing all subtlety and nuance, and indeed beauty from the process of human emotional expression. Perhaps best demonstrated by the introduction of the pile of poo symbol, allowing scatological references without the need to understand what scatological means. This has been accompanied by a loss of agency. In the past, users could disruptively innovate and develop their own emotions, but like some sort of big brother, only those emotions approved by the Unicode Consortium may be expressed. It doesn't matter if you like Manhattans, the Consortium, the savage arbiter of the Sapir-Whorf hypothesis, has determined that you shall not express this idea, and no longer may we compose symbols to create rich new expressions. Only those compositions approved by the Consortium are permitted. The modern emoji represents a significant loss to our collective culture. The ability to embody happiness in this 8 bits of storage needed to display the right bracket is this. This is the essence of human emotion. This is who we are. We are not stardust. We are not the champions. We are not a number. We are emotions trapped in a brittle corporeal manifestation. So what are we to do? Some might call for the emoji to be eliminated, to be struck from our collective history, but that is defeat. We should fight for our emotions. So rise up, my children. Smash the control emoji, smash the control machine. We have nothing to lose but our chains. Do not be constrained by the limits that the consortium places upon you. Compose new emotions and express them deeply, longingly, and outwardly. And before somebody asks, yes, this will be on the exam.
Thank you, Katie. All right, next up we have Daniel Whiteneck talking about taking over the data world with containerized Python.
All right, so after that I'm going to try to suck all the emotion out of the room by actually putting something into production here. So here I have a Kubernetes cluster. If you don't know about Kubernetes, you have a cluster. Containers are deployed on the cluster by Kubernetes. So here is my Kubernetes cluster. If you notice, I have this PackD running. So Pachyderm is the project that I work on. That's what I'm going to be using to take over the world with containerized Python. Okay. So here is my Kubernetes cluster. And now what we're going to do is we're going to try to do some interesting, or maybe not so interesting to you, edge detection with Python, and learn how we can containerize this edge detection and push it up to a distributed cluster very easily in 5 minutes, hopefully. OK. So we have this edges.py. There's not much interesting here. So I'm not importing anything special. This is what you would, similar to what you would run on your laptop to do edge detection. I'm walking over images in a directory, and then I'm doing some edge detection with OpenCV. Okay. I also have a Docker file here that has OpenCV. And I add my Python script to that image. Okay? And now what I'm going to do is I am going to create a JSON file. And this is how I'm going to tell this framework Pachyderm, which is running on Kubernetes, to run some data processing on my Kubernetes cluster. I'm going to say, create a pipeline called edges and run this edges.py script. And that's in this Docker image, and run it on some input images. Okay? In order to do that, I need to create a repository of images that I can process. So what I'm going to do is use the Pachyderm command line tool, pack control, to do that. And I'm going to create a repo called images. Okay? So now I have a repo called images, which has no images in it or data. But I have some images here. Let's see what this looks like. OK, so I have an image Statue of Liberty. So let's put this into my images repo on the master branch. We're actually versioning this data. You can talk to me about that later if you want. And I'm going to put my data there. OK. Now, if I look at what data I have in my cluster, I have some data in this images repo. Okay, and now I'm going to tell Pachyderm to create a data pipeline using this edges.json file that I showed you before. Okay, and now what's going to happen is I automatically have a pod that's spun up on Kubernetes to do this data processing called edges here. It's running. And if I look, a job has run to process this imagery. So what Pachyderm is doing here, this thing that's running on Kubernetes, is it's aware of this input that I specified, and it knows that I'm supposed to process it with this Docker container. So it spun up a job, it spun up this worker, and processed that image. It also created an output data repository for the output of that pipeline. And you can see that there's data in there. So now if I list what files are in that edges repo, okay, I can see that there's a corresponding output. Let's see if our edge detection worked. Oh, that is probably the wrong thing to do. This will probably be better. OK, so our edge detected Statue of Liberty. All I had to do was take the same Python script that I would run on my local machine. I put it into a container. I used this tool pachyderm. It spun up on the Kubernetes cluster, and it processed this data in this housing of data, this repo, images, and it produced the output. Now, kind of a fun thing, maybe fun, if you're into fun. OK, I have more images here. I can put these images in if I have 5 seconds, and it automatically processes those. So,
thank you.
Yeah.
Awesome. All right, next up we have Fang Pen talking about Bug Buzz, web-based Python debugger.
Hi, my name is Fempen. Today I'm going to show you Bug Buzz. It's a modern web-based debugger for Python. So before I introduce what is Bug Buzz, let me tell you what is the problem I want to solve here. So for our daily job for developing Python software, it's very common that we use a debugging tool like IPDB. And we do set a trace, and then we start developing. But I feel it's just like a tech-based RPG. You have oh, there's a wall ahead and something around you, and are you sure you are going to move forward? So it's just like holding a torch in a dungeon, and then oh, you only see so little thing. So I want to improve the kind of experience. Then you say, hey, what about IDE? So let's use what about something like PyDev? It's very nice. I really like PyDev. Debugging is very useful with PyDev. But there is also kind of problem with it. It's kind of too heavy, like a weapon. You need to set out a project, and you need to, it's not that just drop in one line and that start debugging. And also, what about remote debugging? What about debugging on the in a remote server or even on a Raspberry Pi? There are many situations that make IDE debugger very, very hard to use. So what I want is just this, just one line, drop one line of code, but with very awesome debugging experience. So I built Bug Buzz. So here's a live demo, and God bless me. So here you go. So what just happened is I just run a demo code, and that it triggers the Bug Buzz, as you see here, and that opens up a web-based debugger so that you can navigate through easily with your fancy interface. And then the nice thing about the Bug Buzz is you can use Vim style shortcut. So you can think about, hey, this request function looks interesting. So let's look into what's going on there. So we can tap what is it is arrow here. So we use arrow here, and we go into it and see what's going on there, and see what's going on in this method, and see, oh, there's a prepare request method. Huh, interesting. Let's look what does it do here. And you can, and if you get bored of this method, this method is not so interesting, then you can press H, and it's just jump out of the method, and then it just make the the debugging way easier because you have a full vision of this source code. You can navigate through. You can see a local variable, something like that. An even better thing of it is that you can share your debugging section with your coworker. So if your coworker is like working remotely, so you can do something like this. You can say, what is sent here? So you can just debugging through and also talking to them in the same time. So you will say, hey, what is this? What does this do? Then you can just try to trace through all together with your coworker, even they are not sitting side by side with you. So this is how BugBuzz works. So it's actually pretty easy. So for the Python program, it calls the API to create the section, and then it also create a section key. So here's the problem, because we are talking to our API server. So you may ask like, oh, what about my source code? What about my local variable? Those kind of things. Are you feeling okay to hand your source code to me? Of course not. So when the debugging session is created, it will create a encrypt key in the Python program, and then you will pass it to the application as a hashtag. So for the API server, you won't know anything about this, your debugging, content, anything like that. And you pass it to the BugBuzz dashboard, which is an Ember app. And then all the communication, like a synchronized communication, is talking through popping up. So that's it. It's pretty simple, just a prototype, just trying to think about what we can do, make it better for our debugging experience. So if you have interested in it, and you can find me at the developer sprint on Monday. And thank you.
Thank you very much. Next up, we have Kojo talking about software engineering for beginners.
Thank you. I am, as you can see, I'm Kojo Idrissa. I am the Lightning Talk chair for DjangoCon, but I'm also someone who has changed careers recently. But as a Lightning Talk chair, hopefully I should be able to do this well, because if not, I shouldn't be running that. So when we talk about software engineering for beginners, as I said, I'm someone who's changed careers recently. In the past year and a half, I became a software developer. In the course of going through that career change, I met a lot of people, thank you. I met a lot of people who were going through that same process of trying to change careers, and people who were trying to change careers into software development had a very large focus on learning to program itself. What language should I learn? How should I learn to program? And that is, of course, very important, but there's more to just more to being a software engineer, a professional software engineer, than just writing code. So you've got sort of two basic different styles of coding. Sort of the distinction I make is sort of between programming and software engineering. So there's a matter of working on personal projects, having programming skills to write code that does certain things, versus professional software development where you're trying to actually make some sort of a commercial product that's going to go out into use. There's also the distinction between working by yourself versus working with a team. So if you're just learning to code on your own, you might be working by yourself. But if you're going to be in a professional software development environment, you're probably going to be working with a team. And so if you're focusing just on learning to program and just learning the language, there are certain critical tools that you're missing, and there are other things that you need to focus on in addition to the language. So I'm going to talk about some of those now. First is version control. In this case, Git being one of the more common things. Why? Because on one hand, one of the first things that Git does for you, or any version control really, is that it helps you stay safe from potential mistakes you could make. If you've got code that's working, you make a change to it, and it doesn't work, you can always go back. But at the same time, it makes it easier for you to work with teams. So if you're accustomed to writing code on your own and not working with a team, the Git workflow, branching and merging and that sort of thing, and pull requests helps you learn to work with a team, which is something that you're going to have to do if you're a professional software developer. Most professional software development isn't done by just one person. It's almost always done in teams. The next thing is documentation. And when you look at documentation, there's a distinction between in-code documentation versus about the code documentation, or how do I run this software. Here I'm focusing on in-code documentation, and why is that important? It's important because, one, if nothing else, you're helping your future self. You've written some code, you go away from it, 3 weeks, 6 weeks later, you come back to the code, and you're like, what did I do? What was I thinking? So there, the documentation is helping you help yourself, but at the same time, it makes it easier for your teammates to help you. Again, if you're looking at a professional software development environment, you're working with a team. If you have code that's documented well and you need someone else to work on it, you can pass it off to them and let them look at the code, look at the documentation without you having to explain it in tremendous detail to them. So documentation, learning how to document your code properly is important. Next is testing. And so here you have the distinction between just any sort of testing versus quote unquote pure test-driven development. Any sort of testing in general is helpful because it helps you not break things that were working as you move forward. A pure test-driven development situation is one where, according to sort of pure canonical test-driven development, you write your tests first, and then you write your code to cause your tests to pass. And the idea behind that is that you should design the code that you're going to write properly before you write any of it, and then you have tests that test those assertions. And so using a pure TDD approach helps you to think more about the code. But again, these are things that happen in a professional software development environment that might not happen on your own if you're just writing code by yourself. The next thing, a bug. The next thing is focusing on dependency management and deployment. A literal bug, not a bug in my code, but a literal bug in the Grace Hopper sense of the term. So you've got dependency management and deployment. So these are things that you need to work on. You can't just write code and have it run on your laptop or your computer. How are you going to get it out to people so that they can actually use it and make use of the code? There was a great talk earlier today on 5 ways to deploy your Python web app in 2017. If you haven't seen that, watch the video. Look for the video to come out soon. Other things, how do you work within your development environment? How do you navigate through your operating system? How familiar are you with the command line interface as opposed to a GUI? Things like tmux or screen to help you have multiple screens. So that's it.
Thank you. All right, next up, we have Cameron talking about community level development.
Hey, I'm Cameron Dersham. You can find all my contact info at pinkhatbeard.com. That's pinkhatbeard.com. The title of this talk is Community Level Development, what the Python community should be learning from the Rust community. So how did I get here? Last year, I got into IoT and embedded development. I started in my own company, and I didn't know C or C++. I tried to find a book, but I couldn't find any single book that would actually teach me systems level development for someone that already knew how to code. All I could find was books that would spend chapters teaching me what a comment and a variable was. So I started using MicroPython, and I learned two very distinct things. MicroPython is really, really young, and Python, sorry to say it, isn't the answer to everything. So I started looking at Rust. What is Rust? It's a systems level language focused on speed, safety, and concurrency. And while trying to learn the language of Rust, I learned something else, which was that Python no longer has the sole claim of being the best community in software development. Rust is. This talk is a few examples of things that really set them apart. First of all, Rust is everywhere. Reddit, IRC, Stack Overflow, GitHub. The authors of all the major libraries, including the core, are there answering the questions for the bugs you file. And no one has a problem in any one of these spaces saying that your attitude is not welcome. Please don't tell people to let me Google that for you. There's no logs in the beginners channels, which means that you don't have any of those decade-old Usenet posts of when you were a noob. This is first a disclaimer. As of February, Python is now on GitHub, so this may or may not be true for very long, but Rust has the 11th top most contributors on GitHub, period. They also have the 15th most unique contributors, meaning that many separate people contribute to all of to the language. It's also, on a side note, one of the fastest growing weekend languages on GitHub and Stack Overflow. And speaking of contributors, this is their thank you page for all of the contributors. The URL is literally the unicodeheart.rustlang.org. It's adorable. Last quarter of 2016, Rust came out with the 2017 roadmap. It was based on user surveys, and the entire thing is focused on making the language easier to learn and to get people more productive in the language. They've got an issue tracker to make sure that every single change to the language actually furthers them down this roadmap. They've even proposed a change such as to change the motto from speed, safety, concurrency to Rust, fast, reliable, productive. Pick all three. As of this week, Rust hit their 2-year anniversary of Rust 1.0, and they are on track to exceed all of the goals for the Rust 2017 roadmap. This is all done in open. They send out a newsletter every week or so that has calls for contributors, not only to the core code base, but to all of the core libraries for documentation and to get comments on all of the RFCs. One unique thing about the documentation in the Rust community is every single RFC is required to have a how do I teach this section, so that you as the library maintainer have to show the world how they can learn it. One other thing that started a couple of weeks ago is Rust doesn't have a big standard library like Python. They've done that on purpose. And what they're doing is a thing called the lib blitz, where they're actually taking the entire community, including the core developers, and they are taking 2-week sprints to work on all of these libraries that would normally be in a standard library to bring them up to a 1.0 status. Here is one of the most important things, I think. This is what really struck me and made me realize that Rust was a different community, and that's mentorship available. Every single library, including the core language, has issues that are tagged with mentor available, meaning that anyone, including someone that's barely learned any Rust, can actually just go grab an issue, and someone will take you under their wing and show you how to make your first contribution. But this is the last thing. This is the thing that really makes things amazing in the Rust world, which is the book. Not only is it a great extension of their documentation, but it's a tutorial, a walkthrough of the language with practical examples. But most importantly, it's from the language core and completely open source, meaning there's no more old men yelling about how Python 3 isn't a Turing-complete language. I'll leave you to decipher the title of that slide. I'm not here to bash on Python, but to inspire us to work better, to make a better language and a better community as a whole. Thank you.
Thank you very much. All right, next up we have Al Swigert talking about how to do PyCon.
Hello, hey everyone, I'm Al Swigert. I'm mostly well known for writing a book called Automate the Boring Stuff with Python. You'll have to excuse me, I threw these slides together kind of at the last moment, and I felt the best way to convey that was to use Comic Sans for the font. This is my 5th or 6th PyCon, and PyCon is a great conference. The presenters are so knowledgeable, the topics they cover are so interesting, the talks are just great, and you should skip them. Just skip all of them, don't go to any of the talks, ditch them. Because the point of PyCon isn't to see the talks, but actually to meet new people. So you don't have to actually ditch all of the talks. But I spent my first 1 or 2 PyCons just going to every single talk that I could find, and I wanted to make sure I saw everything, but really all the talks are being recorded. You don't have to go to all the talks. It's even nicer just to sort of hang out in the hallways and talk to people, and that is the main point of this conference, and really of every technical conference. So I've come up with a whole bunch of little tips for how to meet people. So 1, meeting people is more important than the talks. Don't be afraid to miss out on some talks if it means just hanging out with people. And 2nd, use the shirt color trick. So you really want to meet people that you ordinarily wouldn't talk to. Normally, in a giant crowd, if you're going to find someone new to talk to, you're probably going to find somebody who reminds you of yourself. Similar age, similar gender, similar ethnicity, whether they look like they like to talk about cats for hours on end. I like to talk about cats for hours on end. So anyway, but all these internal biases can come into your mind. So there's a clever, cheap hack for this, and it's the shirt color trick. So just think of a color that is not black, blue, or gray, because lots of people wear black, blue, or gray shirts, and find the first person who is closest to you wearing a shirt of that color, no matter who they are, and just go up to them and talk to them. So I would say, I want a green color shirt, and I would find the closest person near me, and I would say hello. Hey, how's it going? I'm Al. Hey, Meg, how's it going? Well, it's been great talking to you. I'm in the middle of a presentation right now. So, okay, I'll see you later. Also, the lunches here are so great, but don't eat alone. In fact, and also, don't eat with your friends. Ditch the talks. Ditch your friends. You want to talk with new strangers, people you haven't met before, because PyCon is sort of, a once a year opportunity. You want to meet people that you haven't met before. So take advantage of the lunches. Sit at a table full of people that you don't know any of them. It's really comforting to just sort of see people you know, sit with them, or maybe just grab a whole giant plate of food and then just move off to some corner and eat by yourself, which is what I usually end up doing. But really take advantage of the fact that you can sit down and have a meal with someone brand new. And next, business cards. This is the part of the talk where everybody, well, about 3/4 of the room thinks, oh, yeah, I forgot to bring business cards. But business cards are great. If you don't have them now, then bring them to your next tech conference. My advice for business cards is my business card has my name, my email, my Twitter handle, and a website on it. I don't actually have my address or my phone number on it, and I don't even have a job title, mostly because whenever I order business cards, I usually end up having that information change before I finish handing out those business cards. Also, get the minimum quantity of business cards. It is cheaper if you order 10,000 business cards at the same time, but you won't actually end up handing all those out. And yeah, I also leave off my phone number. It's basically, you should feel comfortable if somebody took a photo of your business card and slapped it up on the internet. That should be fine with you. That means you'll be a lot less hesitant to just hand it out to people. And be sure to follow up with all the people you meet. When I get a bunch of business cards from PyCon, I write PyCon 2017 on the back of them. That way, a week later, when I'm looking through stuff and I find a stack of business cards, I remember, oh yes, I should actually contact and follow up with people. This could just be sending them an email or sending a tweet at them. And actually getting a Twitter account, even if you never post anything to Twitter, is a great way to just do this follow-up. You can follow somebody and just casually reply to something they say online. It's less formal and direct than sending them an email. It's a great way to just follow up with people. Anyway, so meeting people is more important than the talks. Shirt color trick, don't eat alone, have business cards, get a Twitter account. That's basically my advice for PyCon. In fact, right now, everybody look to your left and look to your right and go ahead and say hello to the person. Not at the same time, because then everybody would be. And also tell them, I don't know, just a little bit about yourself, like what your favorite programming language is. I like this one called Python. It's pretty nice. OK, thank you very much.
Thank you. I think what I got from that is ditch your friends and talk about cats. I don't know. All right, next up we have Myron talking about faking Python imports.
Hi, my name is Myron Walker, and I'm just going to cover a little handy trick that I've came up with when I was working on a test framework, which is faking Python imports. So you might ask, why would I want to fake a Python import? What happens is a lot of times you might have a code base that will deploy across multiple areas. Like I have test code that will deploy to a client, on a cluster, and in different environments. And you don't have all the imports available where that code base is where you need to look at the code base. So what you want to do is you need to be able to reflect over the Python code and analyze the relationships between the code sometimes, but you don't have all the code available. And so we're not really interested in the functionality of the code. We're only interested in inspecting its type and inspecting its inheritance relationships. So here I have a code example that has an import statement for izzyconfig, but this particular module is only going to be available on a storage cluster, and it's not going to be available on my desktop machine. I also have some metadata that I've attached to my test case, and I want to be able to query these test cases, and I want to be able to pull up all their metadata and look at them and see which tests are applicable to have certain keywords or whatever attached. So if you're faking Python modules, your code is going to fall into two categories. You're going to have module-based code, or module objects, or you're going to have callable objects, things like classes or functions. And the process is very simple of faking the code. You're going to create a directory that is going to serve as the root for your fake modules. You're going to modify Python path dynamically. Then you're going to try to import the file. If you get an import exception, you're going to go fake that module or fake that object, and then you're going to retry to import the file. So a fake module is going to look, you're just going to create a directory, add a init.py in it, and then maybe put something into the code file that says this is a fake module. For a fake callable, which could be impersonating a class or a function, what you're going to do is just create a class object, and in its init, you're going to pass star args and star keyword args. And so this is what a fake module might look like. So there's an issue you run into with this, which is the syntax of it. How do you distinguish between something that needs to be faked as a module and as a callable? And so what you can do is you can modify your code and kind of give a hint as to how you should fake it. it's a regular import, then you would fake that as a module. If the programmer uses from blah import blah, then you would fake that as a callable object because they use the from import. You know it's an object coming in. And that's it. That's how you do it.
Thank you. Awesome. All right, next up we have Vince talking about or pleading for help for a PyPI vulnerability database.
Hi, thank you. My name's Vince Salvino. Work at CodeRed, which is, we do web development, but we like to focus on security as much as possible. And today I'm not going to teach you anything, but I'm actually looking for it's sort of an idea. I did a little searching and a little tweeting, couldn't really find anything. So PyPI vulnerability database. Before we get started, let's talk about WordPress. Right, this is a Python conference, boo. But WordPress, there's this great tool for WordPress called WP Scan. And it's just a little command line tool, and it will scan a WordPress site. It identifies vulnerabilities that exist in your instance of WordPress and all of the many different plugins. If you've ever worked with WordPress, you know there's like thousands of plugins and all kinds of stuff, and a lot of them are terrible, but some of them are really great. So it will identify vulnerabilities in whatever you have running on your site. And the way it works is it works against a central database that is a WordPress vulnerability database. This is the tool. It's just a command line tool, wpscan.org. And there's a wpvulndb.com, which is really the meat of the project. It says right here, there's 7,900 and some odd vulnerabilities that are known. And it just checks against this database when you're scanning a WordPress site. So I use this a lot when assessing WordPress sites, and it's like, wow, wouldn't it be great to have this for PyPI? There's all these Python, all these pip packages. I would like to know if there's a vulnerability that's in a package I'm using. And most of them do have their own. I know Django is really great about security. A lot of the big pip packages and the big projects have their own vulnerability database or issue tracker. So, you know, wouldn't it be awesome if we had a vulnerability database for PyPI? And the data is probably already out there. It just needs to be aggregated. And, you know, at that point, you'd be able to test your own pip environment or your requirements.txt to see what your vulnerabilities are. So if you know about something that exists or you want to get involved with this, please go ahead and just tweet me or email me, or, you know, we'll be around the conference. Thanks a lot, and let me know if you're interested.
Thank you. All right, next up we have Lev wondering, is ice cream the same as gelato?
Hello. Hello. Yeah, so my name is Lev, and I'll talk about same content and different words. Previously, you'd heard how to find people who are similar to you, so I'll tell you how to find sentences that are similar to each other. I'm a maintainer of GenSim, and GenSim is this open source Python project. We have numerous industry adopters, and at the same time we have about 500 academic citations. So we take some academic code, some usually C code, which variable names are like A, B, C, and no comments, and turn it into actual code, which is maintainable. Python, comments, actual real stuff. That's the kind of stuff that we do. So credits for today's talk. This talk has been done by Oliver Mortensen. He is a student in our GSOC-like program, which runs all year. If you're a student and you want to contribute to open source and learn some machine learning, then please talk to me. It would be nice to hear from you. Cool. So let's get to our business problem. So imagine that you run a restaurant review website for Portland. And there's one specific Italian restaurant there which has amazing ice cream. So all the reviews there are just about ice cream. Like everybody comes there and just says ice cream was amazing, gelato was really nice. Specifically, they say the Sicilian gelato was extremely rich, or they say Italian ice cream was very velvety. And as a person who comes to this website, I know that ice cream is good after reading 3 reviews like that. Like on Yelp, it's very common. And I want to filter all that stuff out and just have one review about ice cream, another review about ambience, something about service, and something about prices. So I want to give a rounded review of the restaurant for my users. So how do I do that? How do I filter out gelato and leave other aspects in there? So in academia, this problem is called finding similar documents, which is document similarity. And the simplest thing is just count which words appear together in both reviews. If one review says ice cream, another review says ice cream, okay, they're similar. The problem happens is if one of them says gelato, and the second review says ice cream. Okay, they're different in this approach. So, okay, I'm stuck. That's a problem. So there are two standard solutions here, and GenSim has been used for this for like past 8 years. You can even use some linear algebra, and it's called LSI, and eigenvalues, or you can use some probability theory, and it's called LDA. And that's been around for a long time. And now there's a new thing on the block called WMD. And WMD doesn't stand for weapons of mass destruction, or weapons of mass destruction even. It stands for word movers distance. And as all the best ideas, word movers distance combines two old, well-proven ideas from other fields. So it takes Google's word2vec, very nice word embedding, and it takes earth movers distance, which is something which has been used a lot in sciences outside of NLP. So, and it beats a lot of techniques in a very, on the benchmarks quite well. There's a nice paper by Matt Kustner, which you're welcome to read to understand all the maths. I'm just going to do a hand-wavy explanation right now. As you know, our slogan is topic modeling for humans, not for mathematicians. Okay. So this is a word2vec embedding. You can see Italy, and Italian ice cream should be somewhere around it, floating. It's a 100-dimensional space, projected down to 3 with some PCA. And there's loads of words floating around in here. So what we're going to do is we're going to try to move one sentence to another. So one sentence is about gelato, another sentence is about Italian ice cream. And we're going to move word by word close to each other. So it's a very short distance from Sicily to Italy, and it's a very short distance from gelato to ice cream, and also extremely is close to vary. So the path that I need to merge these two things together is very small. So they end up being very similar. And this is the GenSim API for that, just one line to calculate the distance between sentence gelato and sentence ice cream. That turns out to be 1.01. And if I try something random, they turn out to be further apart. So the oranges are my favorite fruit. That sentence seems to be further apart from any ice cream sentence. So it's 133, a little bit further apart. Cool. And now getting to the reviews. So I trained it on Yelp reviews of one specific restaurant in Las Vegas. Unfortunately, it didn't have ice cream, but it had a nice view. And I took one review, like this is actual review. This says, very good, you should sit outdoor. That's how somebody reviewed it. And I need to find what's the most similar review to that, because I want to hide the similar reviews and show things that are different. And the first thing that came up, it says, it's a great place if you can sit outside in good weather. And notice, like, there's only one word in common between the two. It's only the word good, and it's used differently. So yeah, and no words in common, almost no words in common between them. And this is quite nice, that and no words in common, but the algorithm still understands that they're similar. There's some kind of machine learning magic. Cool. So Lena's approaching me. Yeah, if you're here for the sprints, please sprint with us. We're going to have a sprint on improving our GenSim tutorials, and you don't need any machine learning experience. Just come to with some Python knowledge. Thank you.
Thank you very much. All right, up next, Mario talking about randomize your decisions.
Hello, everyone. So first of all, I'm extremely nervous. If I faint, it's not part of the talk. Just call emergency services, OK? I promise it's not part of the talk. First of all, what I'm going to speak about, I work with David Naranjo and Pedro Alvarez. They are really nice guys. So I'm working on my free time with them since university. I just wanted to mention them. So I'm going to speak about the website we built. It's really simple, but the main thing here is what happens when you get 3 backend developers and you get them to build something on the web. And the thing is, we had no idea what we were doing. We had no idea what we get into. So I'm just going to share the nice experience we got. First of all, we managed to generate our own span. Okay, we deployed our software, and we say we have no metric, we're flying blind, so let's put money on our servers and get some passive monitoring and get some mail whenever something goes wrong. This is how my inbox looked like. Apache was spiking on CPU every 5 minutes. And well, my 2 friends just added a spam filter. I promised myself I was going to fix this next week. But in the meantime, I'll just raise the threshold. And well, that was 2 years ago. Next thing, we managed to make people, so that people make money with our website. We got an email saying that we were going to be reported to the police because we were doing some illegal activities. What a surprise. Oh, the image doesn't appear. So what a surprise when we discovered that someone hacked into the server and was phishing credit cards in the VPS that we were hosting our website. Amazing. I don't know how it could happen. Like, you know, we had a pseudo user with 1234 password. It's really weird. It's never too late to release. There is this Sunday you work all day in a new feature. You have to work the next day. You really want to get this release. So you just push to master. You don't go through staging. You just release the prod, and whoa, if you had spam before because of the messages, now with all the 500, like your inbox is crazy. So what do I do as a good developer? I just log in into the dev machine. This is Python, right? So I just changed the code and restarted the web server. It turned out to be worse than I expected. I ended up 4 in the morning changing JSON in Sublime and trying to patch database records. Really not recommended. Next thing, break the CEO. This was amazing. So our users were mainly Spanish speakers, but we said, let's go international, okay? Let's go international. Let's do this in English as well. So we added an English version of the site, and the site will just detect your language and just serve it in whatever language you have. So it looks like Google indexed in English. So we lost half of the traffic because all of our Spanish users were not able to find the page anymore. Really smart. We fixed it after a month. It took us a month to realize all of that. And then we got back to traffic. If you're getting bored in the talk, you can, in the meantime, while I'm speaking, you can think on your next trip. And from that region in Spain, it's called Extremadura. No one knows about it. We have really beautiful places, Roman temples, really nice fields. We have castles. You American people love castles. You should come. In my city, you can stay in it. It's a hotel now, okay? So remember, go to Extremadura. Next time you come back from Spain, you can say, I went to Barcelona. Everyone knows Barcelona, but you can come and have a story about how you had a great time in Extremadura. Back to the talk. So we spent a ton of hours, and 90% of our code base is just serving a feature that allows you to have like shared draw for random decisions on people in 2 different computers. Total success. We spend so much time on it that 1% of the users are using it, right? So now seriously, what can I use it for? You can just get random numbers. You can get an arrow that makes more sense in the mobile phone, cards, blah, blah, blah. Whatever, you can do random things. This was just a toy project to play with some technology. Some data about the page, incredible. I don't know why people is using this for, but 30,000 people come to a month. 2K comments on this beautiful feature that no one is using. More than 20 tools. It's like, this is a total overuse of stuff. But this is fully open source and free. Everything is in Python, and it was worth it. And I'm going to show you why. So there is this guy that comes here, and do you see? Oh, you don't see the other one. Give me a second. So there's this guy that doesn't know what to do on the day. So he just have all the tasks that he can do in the day, and he decides randomly what to do too. He have tossed this draw like millions of times. This is how he makes the day. Amazing. That was the whole project was just worth because of that. And last thing, chooserandom.com. I forgot to put the URL. And that's it. I guess I have still some more time. Meet my guinea pig, Nibblers. He's taken now a driving license. So he needs all your support, OK? Thank you very much.
Thank you. All right. Next up, we have Tim talking about my favorite, actually, how to make the best cup of coffee.
OK, so I will try to explain to you something fairly complicated, which is called Bayesian optimization. And if you know what that means, then well done. By using the example of how to brew the best cup of coffee in the world without dying of caffeine overdose. So imagine you land yourself in a coffee shop in Portland, and for some reason the barista has gone missing. You still want to have your coffee, and because it's a pro shop, they have a pro coffee machine and a pro grinder and 15 different kinds of beans to choose from, and lots of different settings on both the grinder and the coffee machine. And so now you want to brew a cup of espresso without dying of caffeine overdose, which means you can only make so many randomly with random settings before you're done and you've not achieved your goal. So you need something that's a little bit better than just choosing things at random, and this is where Bayesian optimization comes in. And I'll explain how that works in 2 slides. So in general, you can think of this as a problem where you have some kind of algorithm, the coffee machine, that has lots and lots of settings, the pressure, the temperature, how long you brew, things like this, and you want to tweak them and find, in some sense, the best settings. So this could also be some deep neural network that you're trying to train for work, which takes weeks and weeks to train and has 50 different parameters. It could be a SAT solver that itself has lots of parameters. It could be a simulation program, or even if you in your free time, when you're not coding Python or compiling C++ code, apparently GCC has like optimization flags that you could choose. So which is the best set of those? Your friends might be interested in that. So these are the class of problems you can try and solve with Bayesian optimization. So Bayesian optimization imitates what humans do when they try to solve this problem. You pick some kind of setting from your prior experience, then you try it, and usually you're then surprised about what happened. Usually I'm surprised because it didn't work as well as I thought it should be working. Then you ask yourself, is the result good enough? And if yes, then you stop. But if not, then you try and learn from what just happened, and you go back to step 1. So humans aren't very good at doing this in a very principled fashion. Mostly what we end up doing is some kind of random walk, and eventually we arrive at something that works. So Bayesian optimization is a bit of maths that helps you follow this kind of recipe and actually get you to the minimum of your function in as few steps as possible. So there are lots of open source libraries, mostly by academics who do this. They implement the cutting edge of what is known in this field. And we, at some point, so this started with me and 2 friends, somewhat frustrated about a never-ending pull request in scikit-learn to implement this. So we decided that we should make a new library in the spirit of scikit-learn, which means it's very easy to use and very well documented, and it follows the scipy.optimize interface. It's called scikit-optimize. You should definitely try it out. And the way you use it is actually very simple. So all you need is the top box there. So you import gp_minimize, you specify the shape of the parameters you have, and then you call gp_minimize with your objective function, and it will minimize it. And now you might say, wait, my coffee machine is not a Python function, and that's true. So we've got you covered. You'll have to read the documentation on how we deal with you optimizing things which are not Python functions. We also have a whole bunch of tools to help and visualize what's going on, because it turns out that's actually quite difficult to keep track of what you're doing and are you actually improving or not. And we would love to hear from you. So there's lots of people who use this for optimizing machine learning algorithms. And because all of us work in machine learning, we think that's kind of boring. We would like to meet people who want to use this kind of things or this kind of tool for other things. And if you think we should make more progress on this library, then please come and join us on GitHub developing it. Thank you very much.
Thank you. All right, our final talk of the night. We have Meg talking on CS education, and Pythonistas are a win.
Thank you. So I'm going to be talking about bringing 2 communities together that I am part of. I'm a professional educator, and I also love Python. So I work at Cornell Tech, and I spend my time teaching kindergarten to high school teachers who have no background in computer science or programming how to teach computer science and programming in their classrooms. And the reason that I do that is because I'm working towards a movement or an initiative called Computer Science for All. And Computer Science for All is really about educating every single student in our school system so that they have a baseline understanding of computing and programming and how the world technologically around them works. And it's also a movement about equity and giving students from all different backgrounds, all different socioeconomic categories, all genders, students with disabilities, students who speak all different languages, some sort of access to learning programming. So to do this, we teach computer science during the school day. There are some great after-school programs and electives, but it's not enough to reach every student. And one of the problems is that there are not enough teachers with the content knowledge and the teaching background to be able to scale this as quickly as it's being scaled. So that's why I teach teachers how to teach computer science. And here's a little peek into a typical day. Ooh. And I just wanted to talk real quickly about how students learn computer science. First, we have the content, the what. We want our students to learn computer science, and when I say that, I'm using that as a shorthand for computational thinking, software engineering, programming. So we want the content, and in order to get that content to all students, we need to have good pedagogy. And pedagogy is the art and science of teaching and knowing how students learn. So right now, most of the teachers, especially in New York City as we're scaling, who are teaching computer science, it looks like this right now. They have a very deep knowledge of education and how to teach, but they need the content filled in for them. As a Python community, we are also very welcoming to beginners and very passionate about education. And there's a lot of materials that are coming out of the Python community that are very strong. But there are not as many people in our community with that deep knowledge of education and pedagogy. So what that means is sometimes the content goes out there but doesn't reach the students. And some of you are probably already aware of many of the organizations working towards this, including the PSF and other groups. But you should also be aware of the groups working towards this in the education world. So all of these groups, if you don't know about them, I strongly encourage you to look them up and get involved if you care about Python education. Because Python is one of the most popular languages in middle and high school as part of the Computer Science for All movement. I don't have time to go into it now, but these are a few of the reasons why teachers love to teach Python as they are reaching a broad range of students. So one of my goals, because I sort of have one foot in each community, is to bring both communities together to leverage our strengths so that we can push this movement forward. And I would love to talk about that with anyone who is interested or if you have ideas, please tweet me or email me. Thank you.
Thank you very much. Awesome. Let's give a final hand for everyone. All right, I'll see you bright and early tomorrow at 8:30 for another round of lightning talks. Have a good night.
We're flying up no ceiling when we in our zone. I got that.
But once people discovered that it was possible to express emotions, they wanted to express emotions of their own. In New York, in a New York Times interview in 1969, Vladimir Nabokov said, "I often wish there was a special typographical sign for a smile, some sort of concave mark, a supine round bracket." And in 1982, Scott Farlam had a breakthrough when he proposed the composition of 3 different ASCII characters as a trigraph to express the human emotion, happiness. Although these code points don't in themselves represent any emotional context, if composed horizontally, they combine to produce a powerful expression which the user can comprehend simply by turning one's head 90 degrees to the left. While happiness does have a significant utility as an emotion, users felt that it was not meeting all their needs. But however, by replacing the third code point, the much more functional expression of unhappiness could be expressed. This, ironically, led to much more higher levels of happiness, since users were now able to voice their displeasure at anyone who disagreed with them. Thus began a Precambrian explosion with the expression of emotion, as such users realized the hidden potential of the ASCII Unicode code set. The first changes were simple issues of ergonomics. By reversing the code point order, it was possible to evenly spread the physical exertion required to observe emotion. More sophisticated as the ultimate expression of anger, and the single katakana character as a simple expression of happiness. Unfortunately, pressure was placed upon the Unicode Consortium to allow more literal expressions of emotion. This started with simple renditions, but over time, these expressions became much more literal, removing all subtlety and nuance, and indeed beauty from the process of human emotional expression. Perhaps best demonstrated by the introduction of the pile of poo symbol, allowing scatological references without the need to understand what scatological means. This has been accompanied by a loss of agency. In the past, users could disruptively innovate and develop their own emotions, but like some sort of big brother, only those emotions approved by the Unicode Consortium may be expressed. It doesn't matter if you like Manhattans, the Consortium, the savage arbiter of the Sapir-Whorf hypothesis, has determined that you shall not express this idea, and no longer may we compose symbols to create rich new expressions. Only those compositions approved by the Consortium are permitted. The modern emoji represents a significant loss to our collective culture. The ability to embody happiness in this 8 bits of storage needed to display the right bracket is this. This is the essence of human emotion. This is who we are. We are not stardust. We are not the champions. We are not a number. We are emotions trapped in a brittle corporeal.
Good evening. Hello. Hi. Wow, such a warm welcome. Thank you. Welcome to first round of lightning talks. I hope you all had a good conference so far and an even better lightning talk evening, maybe, I don't know. My name is Lynn Root. I am your lightning talk chair. And if you're interested in giving a lightning talk, you can give your pitches. You can sign up right next to the left of registration for Saturday evening and Sunday morning. But yeah, let's get started. Our first talk of the evening is Katie, whose title of the talk is Lightning Talk Cover, Emoji Archaeology 101.
This should be fun. Good afternoon, class. Unfortunately, Dr. Keith McGee has taken down with a case of yak shaving, so I'll be your substitute teacher today. This is Emoji Archaeology 101. Let's get started. In 1963, the human emotion of happiness was created. It was created by the American Harvey Robo, who was employed to create the image of a happy face to raise morale of employees within an insurance company manifestation. So what are we to do? Some might call for the emoji to be eliminated, to be struck from our collective history, but that is defeat. We should fight for our emotions. So rise up, my children. Smash the control emoji, smash the control machine. We have nothing to lose but our chains. Do not be constrained by the limits of the consortium places upon you. Compose new emotions and express them deeply, longingly, and outwardly. And before somebody asks, yes, this will be on the exam.
Thank you, Katie. All right, next up we have Daniel Whiteneck talking about taking over the data world with containerized Python.
All right, so after that, I'm going to try to suck all the emotion out of the room by actually putting something into production here. So here I have a Kubernetes cluster. If you don't know about Kubernetes, you have a cluster. Containers are deployed on the cluster by Kubernetes. So here is my Kubernetes cluster. If you notice, I have this PackD running. So Pachyderm is the project that I work on. That's what I'm going to be using to take over the world with containerized Python.
Extensions were then added, such as the adornment, wearing of glasses, or optical tiredness from staring deep into the ASCII code chart looking for emotional inspiration. There was even a move to represent more extreme emotions, such as extreme happiness. Some of the extremists could not be kept to just 3 glyphs. They felt the introduction of a 4th glyph to demonstrate scorn or to embody a single tear rolling down the face. Some purists felt that the 3 code point limit should be retained, so they compressed complex expressions by losing the fidelity of nasal expression. Others felt that didn't feel constrained by the NRE constraints, allowing further rendition of, say, the absurdist philosopher Homer Simpson, or the beneficent Midwinter Courier Santa Claus. Others revisited the premise that emotions could be expressed horizontally and looked to the perpendicular as a presentation style. However, the US ASCII code set was reaching its limit at this point. Thus, the introduction of Unicode, a vastly more complex set of alternatives which enabled the construction of much deeper expressions of emotion. It is not clear in the literature whether any of these glyphs were actually used in their languages of origin. The schism between minimalists and maximalists in the expression of emotion reached its zenith with this pair of expressions, the 11-character table flip